In this video, we'll be talking about hash functions. Now, why it's important for us to understand hash functions is because they're actually very used in the blockchain. And for us to understand how the blockchain works, which is the underlying technology underneath cryptocurrencies, we need to understand hash functions. So right now what we're doing is just laying out the groundwork for you to be able to understand the blockchain in a further lecture. Okay? So what are hash functions? Hash functions, the definition is a cryptographic hash function is something that takes an input. So it takes something. That input could be a message, like a string, a word, a number. It could be a file, a dictionary, any type of object. Okay? It has that input. And then it takes it, does some computation with it, and returns a fixed size alphanumeric string. Okay? Which this return value, we call it the hash, or sometimes we call it the digest. Now, hash functions are very easy to compute, meaning it doesn't matter how big your file or message is, it's going to be very easy to compute that hash function, that hash message in a way. Now, good hash functions have several properties. They are efficient to compute, right? So you can give them a big file, a small file, an extremely large file, and it's very efficient to compute, very quick, right? That's very important for a hash function because for the reason why we use them requires them to be quick. They are collision resistant, meaning that if you give two different files or messages to a function, the return values are going to be different. They're not going to be the same. Okay. They hide information about the input and they look random, right? So let's give an example of why we would use a hash function, right? And this is something, as a programmer, I used often. So imagine as a programmer, you have two dictionaries. So two dictionaries, or even if you're not a programmer, you have two dictionaries who have a lot of values. Okay, let's say they have apple, they have apple, they have cat, they have dog, and two, and they have a bunch of different other words in dictionary one. Let's call this dictionary one, and you have another dictionary or list. Let's say this is a list of items. Okay. And then you have another list 2, which has apple, cat, dog, but then it has 3. And then it has some other things. Let's say the other things are all the same. Now, usually if you want to compare these two lists to make sure they have the same items, what you would do is go through each item, say, okay, is this one the same as this one? Yes. This one, these two check out. Okay? Same thing. Cat, oh, same thing. Dog, same thing. 2, 3, not good. These lists are different. Now that's a problem because if you have big items, if you want to compare them to one another, it'll take a long time because you have to check each different value. Now, if instead of comparing the items, I compared the hash value of the items, would be way simpler. So let's say I have a hash function here, and the input for the hash function is this dictionary or this list, right? It could be anything. I take it in and I return a digest or a hash, right? This is the return value. And this might be a alphanumeric number, right? So it could be A1 V5. That's the return. Now, if I do the hash of this list, well, the return, the return is going to be something different. It might be A29B. So all I would have to do is compare these two hashes. And if the two hashes are different, that means these items are not the same. If they are similar, that means the item are the same, right? Because a hash function takes in an item, does some computation, right? And then returns a hash value. Now, as we've said, hash values, a property of hash functions is that they're collision resistant. So if these ones are not the same, the values that they return will not be the same. So I cannot have two different items that give me the same value. So I know for a fact if the hashes are different, the items are different. They're very fast to compute. So instead of looping and going through all the list, all I have to do is just calculate the hash. It takes nanoseconds to calculate, super quick, and then I can be able to compare them, right? Also, if I wanted to guess what the list looked like by looking at the hash, I wouldn't be able to because it hides the information from the list, right? So I can't guess what was in the list here by looking at this, and it looks completely random, right? That fills the properties of a hash function, right? And hash functions are used everywhere, not only for applications like this where you want to compare things, but if you want to secure something. If I'm sending a file online and this file has some information, or let's say, better yet, passwords, how do you guys think companies or websites store your passwords? Let's say you you go on Facebook and you type your password, and your password is, I don't know, your password is pass123, which is a really bad password. Don't ever have a password like this. That's your password. Okay, well, do you think that Facebook is gonna save your password in their database? No, absolutely not. Because if they get hacked, somebody's gonna get your password. So what Facebook does, or other websites, they're gonna do the hash of your password. And the hash of your password is gonna give, again, something completely random, right? And they're gonna save this in their database. Now, if Facebook gets hacked and somebody gets all the hashes, he can't reverse engineer to get your password. He can't do that because this looks random. He can't guess what happened, and he doesn't even know which hash function they used. Most of the time, you can know what hash functions they use, but the hash functions are so strong that even if you know, you cannot reverse engineer them. So he can't know that this is your password, and you as a user, you feel safe because you know that this platform does not have your password. It only has the hash of your password. So next time when you come in and you want to log in, let's say you put in the password pass124, well, that's going to give you, because here is 123, here is 124, that's going to give you a different hash, right? So then Facebook gets that hash, maybe it's going to be v982, and they're going to be like, is this the same hash? No, wrong password, try again, right? Then if you put the right password in, which is pass123, they calculate the hash of that password, and that's gonna give the same thing here. Because if the same item will always give you the same return, right? So then they'll be like, oh, yeah, that's correct, right password, right? And then you can log in. So hash functions are used in multiple applications. To make it even clearer, let's create our own hash function, okay? Let's create our own hash function. Let's say we're gonna create a hash, and we'll call this hash function mtg hash, okay? Because every hash has its own name, right? Now, this function, it has to have an input, which is the message, right? Like we've said. It's gonna do some work on this message, and it's gonna give us a output, which is gonna be the digest or hash. Now, I just created some random work, and this work, what we're gonna do, step one, is we're gonna take every letter in our message or number, and we're gonna increment it by 1. So if we get an A, we'll convert it to a B. If we get a 1, we'll convert it to a 2. What we're gonna do next is we're gonna, after each newly created letter that we've created, we're gonna add that letter's number in the alphabet. So A is 1, B is 2, C is 3, L would be 12, right? And then we're gonna return that message, okay? So let's see how that hash function looks like, and if that would be a good hash function, right? So we have the mtg hash, right? And let's give it a message. So let's have the first message be, let's say cat, okay? So if I give this function the word cat, what it's gonna do is first, it's gonna increment everything by 1, right? So C becomes D, A becomes B, right? And T will become U, right? Then, so that's step 1. Step 2, let's add the letter of each of these after them. So A, B, C, D. D would be 4, so we'll put D, and then after D, we'll put 4. B would be 2, so we'll put B2. And U would be 21, so we'll put 21 here. So this is the hash value would be D4B2U21. So if this was your password or your message that you wanted to return a hash, this would be the return value. Now, if you looked at this, you might not be able to predict that this came from the word cat. But then let's say you give it another message. You have another message, and this is message 2, and this here you say dog. Well, again, step 1, we take the message dog, we increment it. So D would be F, right? We'd have O, so that would be P, and we'd have G, which would be H, right? We increment everything by 1. Step 2, we add the letter. So F, the letter for F in the alphabet is D. Oh, sorry. So here should be D, E. So E comes after, let's erase this. So after D, there's E. It's not F. Apologies. E. So E would be A, B, C, D, E, 5. So we'll put E5, right? Then we have P. P is the 16th letter in the alphabet. And H is going to be the 7th letter in the alphabet. So the message or the hash would be E5P16 H7. So we have this hash. Now, if you did these two messages, you might find that something is similar. Oh, we have these numbers that came in from nowhere. You know, what are these numbers here? Maybe I can take them off and they're worthless. You know? Oh, and hey, E, this is the letter after D. Maybe if I just subtract one from each of these, then D, before P is O, before H is G. Oh, I have dog. So you can reverse engineer it. And you notice that because by trying different messages, you saw that there was a pattern and you can reverse engineer it. So this would be a very, 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 very bad hash function because it does not, have the properties that a good hash function has. A good hash function would, efficient to compute. This one was efficient to compute, very easy to compute, right? Hides the information of the input. It doesn't hide them. It doesn't hide the information. I could see that information there, right? So somebody can reverse engineer it. The output looks random. It doesn't look random. So that's a very bad hash. Collision resistant. No two messages could look alike. I guess that might be true. We'd have to test it more. But it's not a good hash function, right? Obviously not. And also the return should be a fixed size alphanumeric string. These ones were not fixed size. If I had a longer message, it would return a longer message. So that's not a good hash function. Now, if you want a good hash functions, we can look at the other ones, but this really serves to show you what is exactly a hash function. Anybody can create their own, but if you really want to create a good hash function, it's super hard, right? Now, these are actual hash functions, right? There's the message digest 5, which was one of the first ones created. Then you had like the SHA secure hash algorithm, which is the most widely used hashing algorithm out there. SHA-1 was the first one that came out, then SHA-2, and all of these are like subsets of the SHA-2. So SHA-1 was super secure in the beginning. Governments used it. Everybody used it. Now, with computing power being so strong, people have been able to reverse engineer it. So it's not a secure hashing algorithm anymore. People don't use it. The most popular one right now is the SHA-256. It's actually the one that Bitcoin, the Bitcoin protocol uses, right? So these are very secure, SHA-256, 384, and there's way many more hash functions, right? Very secure hashing algorithms. And we can look at it right now and see how secure these ones are, right? If I open this, let's see here. So yeah, you have, what's this? You have a bunch of websites where you can give a message and it returns you the hash based on that algorithm, that cryptographic hash algorithm, right? So here there's a website that converts things based on the SHA-256 cryptographic hash function. If I go here and I say cat, well, this is the hash of cat, right? Cat, T. This is the hash of cat. Now you see that this looks absolutely random. It hides the information from here. You cannot reverse engineer it. And if I had something else, like let's say dog, it would give me something completely different. So it's collision free and it's always a fixed size return, right? And I can write something here, and this is, let's say I write a long sentence like Montreal Trading Group is the best one, okay? For this message, okay, and let's actually input this in a Word document. Let's go here, and I'll go, apologies. Let's go in, or a text file, or Notepad. Let's go Notepad++. Here we go. Okay, so for this message, oops. So for this message, I have this hash, right? Now, imagine I change the message just by one letter. One letter. Instead of one, I'll put 2. Look at this. Just for a 1 letter change, right? Look at the new hash function. It's completely different. Completely, right? So this algorithm is so good that if you change just slightly anything, the return is completely different. So if you compare the hashes, you know the variables are different. Very secure. You can't reverse engineer it. So this is a secure hash function. And again, this was just to, make you understand what hash functions are, how they are used. They're used everywhere for security, and there are very strong hashing algorithms, and there are weaker hashing algorithms. And with times, we need to evolve the hashing algorithms to make them stronger because computing power becomes better, and then weaker hashing or even hash functions that were strong at one point become weak, and then we need to use something more secure. Now, once we get to the blockchain course, we're going to see how hash functions fit into the blockchain and how they make all the properties or protocols of the blockchain work in a way. So I'll see you guys in the next lecture.